Hello everyone, myself Sita chettri, having roll number 21NS0158, student of Namchi Government College, BSc second semester. And today I'm going to discuss about the compound microscope, which we are already familiar with. But before starting, I would like to thank our HOD, Sir Sabatrai, Dr. C.P. Khatiwara Sir, and the entire Department of Physics for giving me this opportunity to make a video on this particular topic, that is compound microscope. First, we need to understand what is compound microscope. Compound microscope is an optical device or an optical microscope with a high resolutions, and we use it to see a magnified image of tiny objects which we cannot see with our naked eye. And now you might thought why we use the term compound. The term compound refers to the uses of more than one lens in the microscope. We already know there are two types of microscope. One is simple and another one is compound microscope. And in simple microscope we use only one lens, and in compound microscope we use two lenses. That means that is the reason why we call it compound microscope. Now let us discuss the working principle, ray diagram and the calculations of compound microscope. For the ray diagram part, we need two lenses, as we already know that compound microscope is made by two lenses. Both are convex lens, which means they are converging lens. And as for the focal length, we have to take small focal length as well as small aperture. Why we have taken the small focal length is because we have taken this aperture of this lens small, and since this aperture is small, it is mandatory and it is necessary to take this focal length small. And now this is the object. AB is an object which we want to magnify and see through this microscope, and AB is an object, and this lens is very close to this object, and this is the reason why we have called this lens as objective lens. Why we have called this objective lens is because this object is very close to this lens, and this is the object we want to magnify. So suppose see, this is the pipe which one lens is kept here and another one is kept here. So this is the one lens and this one is the another lens. And now let us see what are the speciality of this objective lens. The speciality of objective lens is that this lens has got small focal length and the small aperture. This is the only thing. And the another, as for the another lens which we kept here, so now this lens has the function similar to simple microscope. It acts similar to simple microscope, and this lens, we have kept this lens near to our eyes, and therefore we call it eyepiece. Now how do we do the setting? Now the object is placed slightly beyond this focus, and you might thought when we place this object slightly outside the focus, where will be the image of this object form? Now the answer is the image will form on the other side of this lens, and we already know that the line, now the one ray which came parallel to principal axis passes through the focus. We already know that any ray which are parallel to principal axis passes through the focus point, and another ray we pass it through optical center and it will go straight undeviated, and they will meet actual. When they meet the actual, they form real image, and they form the image of A at A dash and B at principal axis at a point B dash, and this is the object, this is the image of the object formed by the objective lens. Now we are done with the objective lens. Let's see for the eyepiece. For the eyepiece, the image which are formed by objective lens act as a object for the second lens, that is eyepiece, and we know now we pass the ray parallel to principal axis and it will passes through FE, that is the focus point for eyepiece, and another ray passes through this optical center C2 and it will go straight. Now we clearly see here that these two rays are not parallel and they are not intersecting. That means they are diverging rays. So we have, in order to make image, we have to draw dotted rays back side, same side as the object. Now they meet at this point, and the image of A dash will form at A double dash, and image of B dash will form at B double dash. And we have seen already that the image formed by objective lens is also parallel to principal axis, and the image formed by the eyepiece is also parallel to principal axis. So this is the final image formed by eyepiece. So now the final image is virtual. Why virtual? Because these two rays are not met actually, so they form a virtual image, and this is the magnified image of this object A dash AB, and AB is a image. Now I have already told you that eyepiece has a function similar to simple microscope, and now the question is, how do we place this eyepiece such that it acts as a simple microscope? Answer is, the focus is kept outside and this image is kept inside. The image which is formed by objective lens is kept just in between the focus and the optical center C2 of eyepiece. Now this is the object distance for eyepiece, and this is the image distance for eyepiece, and we have already seen this image distance kept on decreasing, and it said in such a way that it became the distance of distinct visions, capital D, which we are familiar with. And now the question is, why we have to adjust it to become the distance of distinct vision D? Why we have to kept this distance to become distance of distinct vision? It is because if this is the distance of distinct vision, we can clearly see the image. So we have to set it that way. And we are done with the working principle of microscope. We have already seen till here. Now we'll discuss about the its calculation, that is magnification. But before that, we need to understand what is magnification and magnifying power. Now let us discuss what is magnification. Magnification is the process of enlarging the apparent size, not the physical size, of a small object. That means we have to see enlarged image of any tiny object. This is magnification. Now let's see what is magnifying power. Magnifying power is defined by the angle subtended by the image to the angle subtended by the object. And we can clearly see from this diagram, this is the angle subtended by image, that is alpha, and this is the angle subtended by the final image, beta. Now let us calculate the magnifying power of the compound microscope. Now let us calculate magnification. I have already told you that this is the angle subtended by image to the angle subtended by object, and this is the angle subtended by object, and this is the angle subtended by image, beta. So magnification will equals to beta by alpha, and since this alpha is very small, we can write this as alpha nearly equals to 10 alpha and beta as nearly equals to 10 beta. 10 beta. Now magnification will become 10 beta by 10 alpha. This let us mark it at equation number 1. Now in triangle A dash B dash C2, A dash A double dash B double dash C2, 10 beta equals to A double dash B double dash divided by C2 B double dash, because 10 is equals to perpendicular by base, so perpendicular is this and base is this. So this is equation number 2. Now in triangle A1 B double dash C2. This is the A1 point because this is same as A, so we can write it as A1. Now calculate tan alpha. Tan alpha is equals to A1 B double dash by C2 B double dash perpendicular by base. Let us mark it as equation number no. So now tan alpha will become AB by C2 B double dash, because this A1 B double dash is same height as AB, so we can write it as AB divided by C2 B double dash. Let us mark it as equation number 3. Now putting the value of this tan alpha in, putting the value of tan alpha and tan beta in equation 1, we get magnification is equals to A double dash B double dash divided by C2 B double dash whole divided by AB divided by C2 B double dash. So C2 B double dash C2 B double dash get cancelled, and the magnification become A double dash B double dash whole divided by AB. Now we can write it as magnification equals to A double dash B double dash divided by A dash B dash into A double dash B double dash divided by A dash B dash divided by AB. Since this two get cancelled, we only get this expression only. So A double dash B double dash and divided by A dash B dash is magnification for eyepiece. Height of image to the height of object is magnification. So this is the magnification for eyepiece, and this is the magnification for objective lens. So the magnification will become M magnification of eyepiece into magnification of objective lens, since magnification equals to height of image to the height of object, and A double dash is height of image and A dash B dash is height of object for objective for eyepiece, and it now I have already told you that eyepiece act as a simple microscope, and we already know magnification of simple microscope is 1 plus D by Fe. We have already calculated in our previous classes. And magnification of objective lens, I have already told you that magnification is equals to height of image to the height of object. So height of image is this. So this is the distance for image, this is the image distance for objective lens, and this is the object distance for objective lens. So we can write it as image distance divided by object distance. Since this object distance is on the negative side of this objective lens, so we have to write it as negative of minus UO. Now this C1 B dash is nearly equals to C1 C2. By the adjustment we can write because they don't have that much difference, so we can write it as C1 C2, which means C1 B dash is nearly equals to C1 C2, which implies that C1 C2 is a length of this microscope. So we can write it as capital L, which is nearly equals to what? Image distance for objective lens. So we can write it as, and similarly C1B is equals to object distance for objective lens, which is nearly equals to focal length of objective lens. So by adjustment we can write it this way. Now we'll get the final expression, that is magnification for compound microscope is equals to 1 plus D by Fe into L by minus of FO, or we can write it as L by FO. So this is the final expression for magnification of compound microscope when the image form is at near point. Now in case the image formed is at infinity, we get magnification as magnification is equals to magnification of eyepiece into magnification of MO. We'll get this, we have already calculated this. So for when the image is formed at infinity, magnification of simple microscope become D by FE. So final expression will get equals to D by FE into L by FO. This is the final expression when the image form is at infinity. So this is the calculation part of compound microscope. Now we'll see the advantages and disadvantages and its applications of compound microscope. First, we'll see the advantages of compound microscope. So due to the uses of multiple lenses, one can obtain detailed information about the sample. This is the advantages number 1. Number 2, these microscopes have their own sources of light. And number 3 is this microscope is user friendly and easy to handle. Now we'll discuss the disadvantages of compound microscope. The magnification of the sample is possible only to a certain extent. Once this limit is reached, the sample cannot be viewed. That means compound microscope has this limit, so we cannot see the image beyond that limit. So this is the advantages and disadvantages of compound microscope. Now we'll discuss the applications of compound microscope. Applications of compound microscope. Number 1, the identification of diseases become easy in pathology labs with the help of a compound microscope. And number 2, forensic laboratories use compound microscopes for the detection of human fingerprints. That means for the evidence of the criminal cases. So now number 3, school uses compound microscope for academic purposes. Like us, we have compound microscope, many types of microscope in our laboratory, so we use this for our academic purposes. And number 4 is the presence of metals can be detected. That means the presence of minerals in the soils and all that we can detect it using compound microscope. This is all about the compound microscope. We have discussed it so far. Thank you.